Hey everybody, today on the N-Scale Engineer I thought I'd show off some progress I've been making on the Speedo wireless train controller. So this thing's got Wi-Fi and Bluetooth built into it. So right now mostly I've been working on the plastic housing. I thought maybe eventually I'd make this out of aluminum, milled aluminum, but for right now, just for development, plastic seems to be working really well. So the big innovation is this ring around the outside that lets you set the throttle. If you can't see that, I'll show you a close-up here in a minute and go through some of the design details. But I think this thing's going to be pretty cool. Let you have multiple screens, so you can select stuff and jump back. So you can have as many screens as you want with an e-stop. So yeah, in this video we'll go through it real quick and see what you guys think. So right now this thing, basically I'm just figuring out all the hardware involved. I haven't really been working on the software at all. It's just the software just kind of proof of concept, proving to myself that I can control a needle with this outside dial around the perimeter. So that seems to be working pretty good. You can even see if I go past zero, go negative, it should tell me that I'm in reverse, and that isn't even there yet. So yeah, lots of work to do. The e-stop isn't working. This is really, the software is pretty much just a blank slate at this point. I just want to get all the plastic housing figured out. So you can see I've been through a lot of different revisions. This is how the lithium-ion battery is going to be housed in the handle. There's a provision for another one to sit in here. These little purchased clips seem to work really well. So yeah, maybe it makes sense to dive into the CAD, and I'll show you that. It'll be easier to see maybe. Oh, whoops, before I dive into the CAD, let me just show you this. This is the LCD. This is a purchased part from Amazon. This is a 2.8-inch round LCD from WaveShare. It's just got a bunch of stuff on the back. It's got, let's see, a real-time clock. It's got a 3-axis gyro, accelerometer, IMU. It's got a SD card reader, so you can put just tons of stuff on there. It's got a lithium-ion battery charger. It's got, of course, the magnetic sensor for reading the ring. And it's all based off the ESP32S3, which is a dual-core processor running at 240 megahertz. And that's got 2.4 gigahertz Wi-Fi and Bluetooth 5 built into it. So you get all that off Amazon for 50 bucks. So kind of pricey, but it's nice that this has all been figured out. It's got a little chip Wi-Fi antenna. It's even got a jack if you want to put in an external antenna. So everything is pretty much based on this LCD, which then fits down into this recess on the plastic. In fact, maybe you can even see the magnet down inside here, ball bearing to drive this ring. You can even hear the detents maybe a little bit. So I purchased a part from McMaster Car. Let's see if I can get this off. Yeah, so you just buy this little ball, spring-loaded ball, and purchase part, and then that rides inside a set of notches on the inside of the ring, and then the ring with this bearing just presses on. So just like that. But it gives you each click is 1% throttle increase or decrease. So it's actually an absolute position, but I think I'm going to program it as relative. That way you could just hit the e-stop and it'll jump it to zero, although the ring won't move, obviously. So, yeah, lots of possibilities. So here's the CAD model of the throttle. So I did almost all of this from scratch. There's a few pieces in here that I downloaded from other sources, just to speed the process up, but almost all of this is original work, so I didn't want to have any problems with licensing or any other kind of grief. So and to be honest, a lot of this is just modeled to get the bare minimum done. So like this is the LCD. Although that's just the raw LCD, let's go back and look at the assembly, which shows a little bit more parts. So yeah, so there's a USB connector I downloaded, but that's about it. So just to get the placement of that thing right. So yeah, I just created this off the drawing that was provided by WaveShare. So just to get it rolling. So that's that guy. So let's dive into this a little bit. So I'll hide some of these components. Hide the LCD. So now I can look down inside this thing. Oh, I just hid the LCD, not the connector. Let me hide the whole thing here. There we go. So let me also hide some of the stuff on the back, this grip on the back. We'll hide this rear housing for a while. And then, so here's the dumb batteries and stuff. We'll hide that too. Hide, and then the lithium cell, we'll hide that. And now we're down to just the ring around this thing. So you can see this thing spins around as you turn it. So, and there are the detents down in there. So if we hide the ring now, well, let's cut it. If we cut it this way, let's spin that 90 degrees so we see that detent more clearly. So we'll change that to exactly 90 degrees, an offset of 0. So now you can see that little detent part that I showed you earlier. This is the McMaster car part. This is pretty inexpensive. It's only like $2.50. The only problem is, you know, the shipping. I think I ordered 4 or 5 of them, and so 4 or 5 of them, and the shipping were basically equal. So you can see how that ball is going to snap into each one of those detents as the ring moves around here. So there's a magnet. I didn't bother to model the magnet, but the magnet sits down in there, and there's the chip on another little circuit board. This is another purchase part from Amazon. Again, relatively inexpensive, and this whole thing then rides on this ball bearing. Let's hide this ring now, and you can see here's the ball bearing with that circuit board. Let me turn the cut off. So yeah, there's the circuit board sitting down in there with the magnet right above it. So and a couple of slots for wires to come through. Here's that opening for the USB to reach through. Yeah, more clearances for wires. The SD card sticks out a little bit, so a little pocket for that. I made this a through hole past the detent guy, so you know potentially you could get in here with a set screw and adjust the height of this thing. I put it down extra low, but this thing could be pushed up. I thought I could grab a hold of it, pull that thing up. Oh, maybe it's married to the bottom with a mate. But this thing, in reality, if you had a set screw, you could screw that in here and push this thing up to get the exact amount of pressure on the detent that you're after. So that's the top half cover. Let's turn on the back again. Turn that back on, and we'll actually hide this top housing. And then we'll turn on the let's see, there's a battery holder. We'll look at that. There's another one, and then the actual 18650. So yeah, there's room for 2 of them in here, which is probably overkill, but yeah, and they're going to run in parallel, so you can actually run with just one of them. So you could actually have the thing running and pop one out and recharge it while the other one's supplying power. So that might be kind of cool. So and then made a couple of these grips just to cover up some of those slots. So let me turn that back off for a second. This slot in the back is so you can push the battery out. So you could take the grip off and reach in with something and push this battery out, because I thought if you had two batteries in here, it's going to be really hard to try and, get something in there and try and pry that battery out. So better to have some relief in the back so you could push that out. So I'm trying to think if there's anything else worth talking about. It probably looks pretty simple, but I'm telling you, I spent a lot of time on this thing to get where it is, of course. So keep turning stuff back on here. So that's that guy. Oh, and then inside here, the actual LCD, and then the ring. So unfortunately, I put this notch in the ring so that you could plug in the USB port, and that worked pretty good. But the problem is, with the USB plugged in to do any software development, you can't turn the ring. So I've since made like a temporary ring where this top is cut down to this level, so it's basically half a ring, so that you can rotate the ring without having a problem. Oh, one other kind of cutesy thing. Let me hide this back one more time. So if you want to take the screen out without having to pry the ring off, you can turn the ring and it will eventually line up with the screws that are holding the LCD on. So there's 4 of these guys, so you can reach in with an Allen wrench and take these 4 screws out one at a time, and then you can take the LCD off without having to try and pry this ring off. And the ring's just held onto the bearing with friction, so getting it on and off is something you want to avoid. It's pretty violent, and the more times you do it, the less it's gonna to work well. So, I mean, ideally there'd be a set screw or something, but being plastic, I didn't think that was gonna work too well. So, but this works pretty well, just lining these holes up, and you can take the screws in and out to release the LCD. So that's pretty much it. Yeah, that's pretty much it that I can think of that's worth noting. So this is the build environment for the software, and right now it's just bare bones. There's just hardly anything here at all. So it's all ready to be fleshed out. So there's just like one task here that's reading the magnetic encoder and rotating the needle accordingly, and then looking to see if it went into reverse, and even that's not completed because I haven't built the images yet for it. But so yeah, this is pretty much a blank slate ready to go here. Oh, and then this is kind of cool. Let me show you what's it called, Square Line Studio. This is where you actually build the software, or build the GUI, I should say. So here's my project for that thing. And so this is how you can build the screen. Whoops, sorry about that. So you can, build multiple screens and yeah, so like here's the actual needle itself right there. So you can grab the name and if you give it a pivot point, you can rotate that guy around. So once you're all done making your changes, you just come up to export UI files, and it updates the project automatically and builds all this stuff for you. So pretty cool, pretty powerful for free software. So that's pretty much it in a nutshell. Over the next couple of days, I'm hoping to actually get this thing running on battery power. I think that'd be really cool to see this thing without a cord attached, wirelessly connected command station, being able to control trains That would be really cool. So put a comment down below in the comment section. Let me know if you're interested. I'll find some place to upload all these files so that you could print your own, get a display from Amazon, and start helping with some of the software development, because the software for this is going to probably be pretty large and immense, but maybe not. You know, the libraries look like they help quite a bit. The ones for talking directly to the command station and getting all the locomotives that are connected and all the turnouts and routes, so might not be that bad. So, but still, be kind of cool to have other people working on this too. So put a comment down below. Let me know if you're interested, and we'll get these uploaded somewhere. Thanks a lot.